Hello, my name is David. I'm one of the math teachers here at Hamilton Education. Today I want to walk you through 5 need-to-knows for the Desmos calculator on the SAT. So let's get started. So first, let's do an overview. One, you can find uh, a lot of the functions on the SAT through the Blue Book app itself. You can also go to this link, which will be provided in the channel. Um, but yes, the first thing is Desmos is pretty good at giving you points of interest automatically. So it can typically give you intercepts and intersections of curves by clicking the graph and looking for like little gray dots. One thing that's also helpful is restricting the domain of functions, so that way you can focus on only the values that are positive, or only values that are negative. And then lastly, we'll go over kind of like how to find the solutions of intersections pretty quickly. The second thing we'll look at will be built-in functions. So Desmos has a lot of built-in functions. The ones I'm going to focus on primarily is how to use the square root quickly, absolute value, how to do exponents quickly on the keyboard, trig functions, how to type them up, some statistics that are pretty common, and then some constants like how do you get pi to show up pretty quickly, and then how to convert decimals to fractions. For the third stage, we'll talk about trig functions more specifically and how to go from degrees to radians and vice versa. And we'll also talk about like what things to watch out for when inputting angles into Desmos. For the fourth thing, we will talk about how to use the constants and slider features of Desmos. So Desmos has a lot of cool features built in where you can kind of use the letters that the SAT gives you and just plug in numbers to kind of see which one best matches or gives you the correct answer. So we'll show that in a moment, but definitely things to watch out for is you don't want to use the letter E because E is a number that's preserved. And I usually recommend avoiding F, G, X, and Y because those are usually reserved for functions. So lastly, try to stick to A, B, C, D. You can also use M and N as well, but generally speaking, try to focus if the problem uses a weird letter, definitely you can change it if you want to. And probably the most powerful thing I've seen on Desmos is something called regression, where we can use a table of values to make regression curves, but we can also find some equivalent functions and convert them from one form to the other by using regression. All right, if you're ready, let's begin with the first question. Question number 1 asks the system of equations below intersects at the point A, comma B. What is the value of A plus B? So we can solve this very quickly by hand, but the goal here is to kind of show how Desmos works. So with that in mind, let's jump to the screen. And what we can see is I've already typed in the two equations, with the first equation being the red and the second equation being the green. All right, so if I scroll over here, you can click on the graph to drag it instead of always pressing zoom in and zoom out. And then if you click on the curves, you can see that they kind of highlight the point. So I want to copy that over. Now this question specifically says what's the value of A plus B. So we want to do 7 plus -3, which gives us 4, and that is the correct answer. All right, well, let's look at the next question, see how that one compares. So for number 2, the graphs of the equation below intersects at 2 points. What is the sum of the x-coordinates? So right away, I could try solving this by hand, but with all the fractions and decimals, it would probably be unpleasant. So what I'm going to do is type these equations into Desmos. Perfect. And so I've done typing these in where the red is the first one and blue is the second one. But immediately you might say like you don't see the graph. So SAT College Board knows that you have Desmos available. So it sometimes makes the values be very, very large or very, very small, like very, very negative. So you can keep pressing zoom out until you eventually find it. And in this case, you can kind of see it here. However, one thing you may want to do instead is to kind of make it more focused is use the wrench tool. And now we can set the wrench to be, all right, I'm gonna make it be like -1000 to +1, maybe 2000. gonna estimate that. Okay, maybe a little bit 3,000. All right, and then the y values, I don't need any of the positive stuff, so I'm going to focus on just the negative, so maybe negative 5,000 to 0. Okay, that is looking a lot easier to read, and once again, by clicking the curves, it typically gives you the points of intersection. So for here, the question was, what is the sum of the x-coordinates of these points? So the one of them is 0, and the other one is 1,800. So the sum of it would be 0 plus 1,800, or 1,800 is the final answer. Okay. Some other things that are kind of interesting is that if you type in dot x here, it gives you the x value. So you can like kind of get the x coordinate from it if you'd like. You can also erase the parentheses and commas. So things to be aware of. All right. We did that one. Perfect. Let's go on to the third equation for points of interest practice. So for number 3, we have consider 3 different equations. I know the first one is a circle because it has a form of x squared plus y squared is equal to a number. The second one looks like a parabola in vertex form, and the third one looks like a line. So we're going to type them in, and then we're going to look for the distinct solutions. So once again, you might need to press home screen to kind of get back to the normal 10 by 10, or adjust the window as you need to. So with this one, looking at it, and again, you can zoom out, which might look there's one solution, so B, but by zooming in or adjusting the window, you can see that although there's lots of points of intersection, there's no place where all 3 of them intersect at one place. So the correct answer here is A, it is 0. So definitely pretty tricky, and that's one of the challenges with Desmos. If you see all the points of intersection, you might be tempted to pick that. So hopefully that helps you for the future. All right, on to the second part. What are the built-in functions in for Desmos? Okay, so with the built-in functions, they're in the bottom, so it's a little keyboard, and there are a lot of different options in here. So the SAT kind of wants you to not know what they are, and so then spend a bunch of time looking through, trying to see if the thing you're looking for is in there. So one thing we summarized earlier is some of the major ones like sine, cosine, tan, but you can type them out. Mean and median, there's min and max, there's also standard deviation. These other ones you don't need. You won't need list operations, you won't need histogram, you don't need probability distribution, you don't need inferences, you don't need calculus for the SAT, you don't need hyperbolic trig functions. Geometry would be nice, but it doesn't really work. But if you want to use distance and midpoint, it does require that you do the distance and midpoint and then do 2 points. All right, we're not going to use sound. And then number 3 would be helpful for the ACT test, but we're not allowed this on the ACT, so it's not as helpful for the SAT. So most of the stuff is at the beginning, and you can also type it in. All right, let's jump to question 1. Set A consists of 10 distinct non-negative integers, and set B consists of by adding a positive constant k to each element of set A. Let the mean of A, the range of A, and the standard deviation of A represents the mean, range, standard deviation of set A, and respectively, similarly define mean B, range B, and standard SDB. So those are for set B. Which of the following statements must be true? So one of the things I did first is I did something called a list. So a list is you type in something, so it could be A or X1 or something like that, and then you do a square bracket, and then you can type in numbers. So I'm typing in 10 numbers because the question said 10. It did not have to be in consecutive order, but it didn't say it couldn't be either. So I'm just doing these as an example. Now, how do I get to add K to every element in A? Well, I do the same idea, but I just do K is adding to A. And you can see here, it does that automatically. So if K is 1, then 1 turns into 2, 2 turns into 3, 3 turns into 4, and so forth. Something that's interesting, if instead it had to multiply, it works just as well too. So keep that in mind that if you ever need to do list operations, there are ways that have this done quickly on Desmos. All right, well, we don't know what number we're adding, so I'm just going to make it KB3. Again, it can be negative. because it had to be a positive constant. All right, first off, how to get the mean of A? I could get my calculator out and type in 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, 8 plus 8 plus 9 plus 10, divide by 10, and get 5.5. However, by just setting the list up once and then doing the mean of A, it calculates it for me automatically. And then B, which was just adding K to every A value, it then also quickly finds the mean. So I don't have to add up 4 plus 5 plus 6 plus 7, 8, 9, 10, all the way up to 13. So one thing I noticed is that the mean of A is less than the mean of B. In fact, it's actually explicitly less than 3. So one thing that's interesting for statistics, if you add the same number to everything, both the mean and the median go up by the same amount. So if I change this to a 2, now it goes up by 2. If I change it to a 5, now B is 5 more. This question doesn't ask about that. It just asks how do the means compare. So we can pretty safely say that the mean B is bigger than the mean A. One thing you might have gotten wrong is if you use K as a negative number, you might have thought mean A was less than mean B. All right, let's look at the range part. Range is going to be max minus min. Now, you can quickly usually just do 10 minus 1 on your own. However, if you want a range formula to type in, it is a little complicated looking, but it looks, you take the max of A, once you have that list defined, and then the min of A, and subtract them. So that was 9. One thing that's interesting here, if you add a number to each element in A, the range does not change, it's still the same. If we had instead multiplied it, then the range would increase. So if you were thinking that range must also increase, you might have been thinking of if you multiply by a constant versus adding a constant. On that note, how about standard deviation? If you had multiplied by a number, the standard deviation would also go up by a factor of k. But in this case, since we added a number, the standard deviation is exactly equal. So we can eliminate Roman numeral 2 and Roman numeral 3, so the correct answer is A. All right, let's look at question 2. The function fx is equal to the square root of x plus 4, and g of x equals to absolute value of x minus 2 are graphed on the xy coordinate plane. How many real solutions does the system have, and what are they? Okay, so one thing you may notice is that there's the absolute value button down here, and there is the square root function down there. So one thing, though, we can do is we'll just go to the function that I already set up. And I want to show you something helpful. If you type in the letter SQRT, so square root, it then converts it into the square root symbol. So that can be faster than looking for your keyboard. Absolute value on your keyboard, there's a vertical line usually underneath the backspace or delete button. So if you do that, you press the vertical line and then do x minus 2, it will work. Alternatively, you can use the symbol the abbreviation ABS, and then do x minus 2, and that will also work. Okay, so to solve this problem, once we have set up the function, we can quickly click on the answers and see that there are 2 solutions. So it's not A or D, and the solutions are going to be 0 and 5. So we can see that copied over. All right, let's look at the last equation using built-in functions. All right. All right, so we've typed in the function p of t is equal to 250 e to the 0.04 t plus 50. But how do we type that in? So ready? So I did p of t just because it was letter p of t, but you can also do f of x. So 250, and then e is just a letter, and then the exponent button. So that's usually you press shift and the number 6 on your keyboard, and that moves it up a little bit. So that is one of the ways you can get the exponent button in there, and then make sure to press right on your arrow pads on here to get out of the exponent so you can type it in. Okay, in this equation though, we have the price is in thousands of dollars for T or since the number of years since 2018. What is the minimum housing price in thousands of dollars predicted by this model? Well, one, again, I don't see anything here, so I might have to zoom out a bit. All right, so we kind of see it eventually, right? Now, one thing you have learned in your math class is that exponential functions typically don't have minimums. They go down, down, down forever. There's actually something called a horizontal asymptote at y equals 50 here because there's a vertical shift. But this question specifically said t starting the year since 2018. So that means we're not focusing on when all x values, we're only focusing on when the values start at 0. And then once we do that, well, we can kind of see that the value is going to have a minimum at 0, 300, which is why the answer was C. So kind of tricky, but also hope you found that pretty easy to do. All right, next we're going to go on to the trig functions. So when working with trig functions on the Desmos, you have to be mindful of what mode you're using on the test. So let's load up the first question. Third one, second one. Perfect. Okay. So we have two triangles not shown that have the following properties. One, we know that triangle ABC is similar to triangle XYZ. We know the sine of A is equal to 1/3. We know the sine of Z is equal to 2/7. What is the cosine of B rounded to the nearest 10? So first off, because the triangles are similar, that means the angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. All right, so we can solve for angle A in degrees by doing sine inverse of 1/3. But this is probably not what you got when you tried doing this on your own. And that is because you need to make sure to change between degrees and radian mode. So if I go back and do radian mode, well, then what happens here, we get 0.33 for the radian, 0.27 for radian, and now we kind of get some weird answers here where like this cosine of the radian measure doesn't make sense because we're doing 180 degrees minus some radian measures. But that's all designed to get you tripped up and pick D. But if we go back to degrees, then the sine inverse of 1/3 is 19. So how do I do that? Well, I type in sin for sine. I use the caret button, so shift number 6, -1 for sine inverse. And then I have to use parentheses, 1 divided by 3, and then I like to close parentheses. All right, we can solve for z doing the same thing. So that, I apologize, should be tangent. So we'll make that edit. There you go, tan z. And so similarly, we do tan x went -1, then 2/7, and we get 15 degrees. So now that we know z, which is also the same angle as c, and we know a, which is also x, we can then find b, which is the question, by doing 180 minus these two. Now, you can do 180 minus 19.47, 21.8, sorry, 15.94. There you go. And then you can get the sum of those measures and get the cosine that one. That's approximating it. However, what we could have also done is done the cosine of all of it. So 180 minus sine inverse of 1/3 minus tan of 2/7. And that way you don't have to copy numbers down because on the SAT, again, you can't copy one number down to the other. So you do have to type it. And that means you might run into typing errors. So I picked the answer C for this problem. Again, it's a pretty weird question where, again, like you're going all around to find the different measures. But as a good reminder, a triangle does not have to be a right triangle to do sine inverse of a measure. So keep that in your mind. Okay. Question 2. Find the angle theta where theta is between 0 and 180 degrees. So we probably want to have our answer in degree mode, not radian mode. All right, let's load it up. So once again, I'm going to turn this off for a moment. You would probably have done sine x is equal to 0.1. And this kind of can look kind of confusing. So one thing you can do instead is kind of, instead of making it equal to each other, maybe make it minus. And that typically shows you where it's going to be zeros. Then we can find those values pretty quickly. We're looking from 0 to 180, so these measures might also be tricking you as well because these are the radian measures. So what we could do is we could show it a degree mode, and then you might get stuck though because it doesn't look right. But that's because the degrees are from 0 to 180. So we need to go back and change the x values to be from 0 to 180. And then we can see the angle pretty quickly. It's 49 degrees right there. However, if you had done it in radian mode, one thing you can do is you copy that point over and you do the dot x to get the x value, and then you convert it to radians, convert it to degrees by doing 180 over pi. So that's another way of getting the answer. However, what they really, really wanted you to do is round it to 0.8 or 0.9 because that's the radian measure for this question, and then you get it mixed up. All right, so hopefully that makes more sense. Let's go on to question 3. Question 3 is a unit circle. It has a radius of 1, going from B to C. And we have point A that lies at M, N, and it lies on the terminal side, where angle ABC is going to be an angle greater than 3 pi over 2 in between 2 pi. So this is in radian mode. So you were just in degrees, so if you're going to type these in, you may want to go back to radian mode before typing them in. And so the question seems very challenging, and you may be tempted to use your unit circle knowledge, which I applaud you if you were able to figure out using your circle knowledge, but you have to remember this is Desmos. We have a calculator. We can just type them in. So what would it might look like if we typed it in? All right, so the first one, so we have 19 pi over here. And pi over here, and then so pi over 4, 45 pi over 4, and 83 pi over 4. Now, one thing you may notice is that for C and D, instead of keeping the negative on the right-hand side, I moved the negatives to the left. Now, from here, you might get hyperfixated on what the number should actually be, but really what we're focused on, since it's in quadrant 4, the M should be a positive number and N should be a negative number. So look at the first one. The N here is a positive, we want it negative, so A has been eliminated. For B, M is supposed to be positive, but here M is negative, so B is eliminated. For C, we get 0.7, which is, again, not supposed to be positive, it's supposed to be negative. And then lastly, it leaves us with D, where we wanted a positive number. Okay, so definitely, I hope you found that helpful. And a reminder is that you can type these values in and see what the values are instead of trying to remind yourself on unit circle values. If it was pi over 4, 3 pi over 4, those are more common unit circle values. Definitely you can use those as well. All right, let's go on to the section 4. So this one is probably by far one of the most helpful, where it's when you have constants and sliders in a problem, or you have the letters and the equations, and asking to solve for something about the letters. So this first one is pretty intense. It's a system of equations, linear equations, and we have no solution here. And we want to know what the value of A over B is. So let's go look at what we have written down. So one things we have written down is 1.5x minus 3y equals 6 minus half x. And I know the slope of that is 2/3. I did that by combining the x's and then dividing by the -3. For the second one, we have ay minus 4ax is equal to 3/2 plus bx plus 8. And again, the slope of that in terms of a and b would be combine the x's with x's, so you get b plus 4a and divide by the coefficient of y. From here, though, you typically would not get these values. You normally would get b and a being a slider. So let's see what that looks like for a moment. Try. I'm gonna for these ones just change them for C for a moment, and we'll come back to that. So we're gonna add a slide for B. And so in this case, depending on the A and B value, right, like these are clearly not parallel lines. So you may have to try different values to get it to work out. So maybe by changing the A value a bit, kind of looks like that would be kind of parallel, but again, you can fiddle quite a bit until you find the right numbers. That one looks pretty parallel. And so in this case, I said, what's like A over B? You could try doing A divided by B, and say, all right, it's about negative 0.3. The answer that's closest to that is D. However, what is the SAT expecting you to do? Well, what we could do, because it has no solution, is focus and set the slopes equal to each other. So that's what I did here. I took the slope of the first line, um, which again, as a reminder, we changed it from B to C. And then we can we can separate it. So be C over A plus 4 is equal to 2/3. You could then subtract it over to the other side. And that will give us C is 5.666. And then from there, because we're looking for A over B, or in this case, A over C, we get negative 0.3, which is D. So definitely seems kind of tricky, but also you can cross multiply and you want the slopes equal to each other because it has no solution. But both ways, you can play with the numbers going back and forth, which can also help you visualize it and also kind of help you like, well, by typing in A over B here, right, you can keep playing with the numbers and like, all right, what numbers can be and look for the one that picks the best choice. So two different ways of doing it. So I hope you found that helpful. For question number 2, it says a circle is given as the equation x minus 4 squared plus y plus 6.5 squared equals 10. And so I typed it in here. So to keep in mind, you can graph circles in standard form or in graphing form, and it will both appear correctly. We have a parabola that's defined by fx equals k minus parentheses x minus 3 plus h. So that 3 plus h is non-parentheses, so it's x minus 3, then adding h to it squared. So I type that in. And then I have different values of k here. And so I could play with random numbers, which is fine, right? But the goal was to find out which of the 4 following choices would give me 4 solutions. So although this does work, a k being negative 2 and h being negative 0.8, that's not one of the choices. So let's go through it one by one. So I type in 4 here and 3 here. Okay, that hits twice. So let's try the next one. Be careful though. It's because I have K first and H second. It's one of the things that you might type them in backwards. So keep an eye on what letters you're typing in. Ooh, that looks like almost 3 times, but still only 2. H negative 2 and K negative 3. And that is 1, 2, 3, 4, which is the right answer. But we can check D just to make sure. All right, that's only 2 solutions. All right, perfect. So we have found the answer to this question is definitely C, and we were able to use the H and K sliders and plug in the values to go through the choices. Let's look at the last equation. The last question for this section. So this one is a one that a lot of people have told me they have trouble with, and we have 2 ways of solving it. Okay. So one way is we type in the equation, so it's in standard form, and then we get the 3 sliders, and we know the vertex is at negative 2 comma 9, and so you can keep playing with these numbers until eventually you get things getting closer. So I kind of think by making the C lower, it kind of seems better, kind of making the B like that. So it's kind of like we're playing around and guessing until we get it to work out. So that's one option, and you can see that's probably pretty time consuming. A different thing we could do instead is use our knowledge about vertices. So we know that the minimum is given. That's a little bit too thick. That's better. So normal vertex form is ax minus h squared plus k. And so we could then do y equals ax plus 2 and then minus 9. And then we want to set that equal to ax squared plus bx plus c. So then we multiply them out. So we get ax squared plus bx plus c is equal to ax squared plus 4ax plus 4a minus 9. Then this is where a lot of students get stuck. One, ax squared must match up with the ax squared, so that doesn't tell us what the a value is. But the bx must match up with 4ax. And since we're trying to solve for the sum of a plus b plus c, we could say a And then the b value is 4a. And then lastly, the c. So c matches up with 4a minus 9 because they don't have an x. And then we're left with 9a minus 9, and what could be the sum? Well, because a has to be greater than 0, then the solution must be greater than -9, so it must be D. Okay, that's all fun and dandy, but how can we use Desmos to help us with that? So if I draw your attention lower to here, we can use the regression trick, which basically does the same thing but has Desmos do it. So I typed in the vertex form on the left, and I use tilde to tell Desmos that we're solving for the letters here. And I have to use a subscript, so you can use x1, x2, and again, that works by just being your cursor right next to the x and then typing a number. And then we set it equal to ax squared, and then I did mx and n already. And then this is very important. Because there are several unknowns in the problem, we have to type in some points to plug in for the equation. So 1, 2, 3 are pretty common because there's no domain restrictions here. But then that would turn the graph on and work out pretty well. So if we go back and change the b value to 6, and then the n value to c value to -3, like that. Okay, that does hit it, and we can see that a plus b plus c is 4.5 in this case. And if we adjust the a value, oops, not the a value, I think the a, perfect. Uh, Well, if we just say value, it should just change the graph, making it go through that vertex over and over again. So, all right. Yeah, one of the cases where a plus b plus c is basically has to be greater than -9. So any answer greater than -9 would work. All right. I think there must be one more thing. Let's see. And okay, there we go. So by setting the b equal to the m, it now shows you kind of like as long if a is 0, then definitely yeah, a plus b equals -9, but then it's no longer a parabola. You also don't want a to be negative because then it would no longer have two real solutions. So a has to be greater than 0, which means that the value must be greater than -9. Cool. By the way, this m and n here, you didn't have to do both steps. Again, I did both because I didn't want to use the same slider in two places. It doesn't work on Desmos. All right, and let's go into the last section. All right, this is my favorite one that I learned recently on Desmos, and that is basically how can we solve for equations and how can we solve for letters in the problem. And you've already kind of seen a preview of it, but right here we've been showing you how we can use this tilde in x1. Let's get some more practice with it. The first one is pretty straightforward. So if you just type in a linear or a quadratic equation, Desmos does a pretty good job of guessing what you are looking for, and it finds it. However, if you do functions that are non-quadratic, such as square root functions, you may find it better to instead subtract the equation on the right to the left and then focus on when it's 0. I have found that to be a lot more effective, and we can do a test example. So if we did 2 divided by x minus 3 is equal to square root x like that. Turn off the blue. Like you can see that I can't click on that dot. So I can guess what the number is. It seems like it's around 4, right? But I can't see what it is. But if I instead subtract it, now I focus on when it's 0 and I can get the value over. So definitely if you're having trouble with Desmos not working as you expect, definitely this might be helping you get the right answer. Okay, let's go on to the second equation. All right, so first off, we started with a circle with a center. So I know that the equation of circle is x minus h squared plus y minus k squared equals r squared. And so I typed in h is 2, I typed in k is -3. All right, how do I get the radius? Well, we plug in a point that's on the curve, and then that would help us get the radius. So what I did is just said r is equal to, and I just did 6 minus the h squared, because I plugged in the point 6, comma 0, and then I plugged in 0 minus k, because again, the y value is 0, and it said the radius was 5. Awesome. Okay, but the question is saying we have a random tangent line that goes through -2 comma 0, like that. And we want to know what the y value is. Now, you can't draw lines like this like freehand, like I can do with Zoom. So what can we do? Well, there's, again, a very key thing that's helpful, and that is whenever you're working with circle and other shapes, you want to think about the radius. So if I draw the radius first, I notice that the radius and the tangent line are perpendicular. So how can I find the slope of the radius? We can do that by using something called a table. So I'm going to delete it, just to type from scratch. So table for table. We type in the center, so that was 2 comma -3. And then we type in the point that's the point intersection. So 2, -2, comma 0. All right. Now, Desmos has built-in regression curves. So we want linear because it's a line, but you could also do quadratic, exponential. Those are probably the two major ones that you'd be using. Okay, and now we have the equation. We can even copy it down if we want to as well. Okay, but that is the equation of the radius, not the equation of the tangent line. So how do we get from here to the tangent line? Well, one thing you may recall is that perpendicular lines have opposite reciprocal slopes. So for the next one, I took the slope of the beginning one and I did -1 divided by it. And then I used point slope form to do x minus -2 comma 0. Now if we turn that on, we now see a beautiful tangent line. So how would we get the answer? Well, now we can type in f of 0. Okay, that is close to 2, but not quite 2. It's 2.6, 2.7. So you can eliminate a. I can then do f of 1. F of 1 is 4, which is what we want, so we have the answer. It's done. But we can check the other ones too. F of 2, well, 2 comma 2 is on the circle, not on the tangent line, so we can eliminate that one. And then f of 6 is kind of seems a little bit too low, but definitely that's not what we want. We want 6 comma 4, not 6 comma 10.66. So we can eliminate 6 comma 4 as well. All right, that was a really hard question, but we made it easy by having Desmos do all the heavy lifting. So it found the slope between the center and the point, and then we use the rules of perpendicular lines to the opposite reciprocal and point slope form to quickly graph a tangent line. All right, let's look at our final question. All right, for question number 3, we have operations with fractions. So definitely when you have operations with fractions, you typically want to think about finding a common denominator and then proceeding with that. That's what the test wants you to do. But it's kind of interesting. So if you type it in as it's written and you did equals, it doesn't work. It doesn't do anything. One thing we talked about earlier is that lines and quadratics kind of solve implicitly, but most other functions do not. So I'm going to subtract the equation over and then focus on when it's 0. From here, the question is asking what's the c value. So if I type in -2, that doesn't seem like it would be equal because we still have a curve. If I type in -1, still has a curve. If I type in -1/2, we get 0, which means that the equation on the left and the equation on the right are the same. So that's perfect. So C is the right answer. But what if I didn't have numbers to plug in? How can Desmos solve it? So what we're going to do is start from the beginning. So first off, I have a fraction. So I'm going to start with parentheses and then divide. That way I get things on top and bottom. So then x1 plus 6, and then x1 squared minus 9. Okay, then we subtract. Again, we have something on top, so I'm going to do parentheses, divide parentheses, and then 3 to x minus 6. And then we could say equals to, and that's a common typo that we run into because we don't do equal signs for regression. We must use the tilde. Another mistake that's pretty common is that you forget to do x1 for all of the x's. So I'll change the equal sign to a tilde and then x1. Now, as a good reminder, you want to set a list of values for Desmos to plug in. So if I try 3, it didn't work. Now we know, before we knew it did work, we know it's -1/2. Why doesn't it work? Well, in the case of rational functions or square root functions or logs, they have a lot of domain restrictions. So in this case, if you put in 3 or -3, you'd be dividing by 0, which is not allowed. So if we type in 1, it works. If we type 2, it works. Make that a D. So it works, 2 works, 3 does not work, 4 works. So again, that is a way to get it done. So I hope you found that helpful. Definitely feel free to message me if you have leave things, comments in the video. I'll be happy to message you back and tell you any other tricks that I see or any other tips you might want. All right, take care.